In this video I will show some brush DC motors. On the screen I have a small brush DC motor that I have disassembled into three components. On the stator there is a permanent magnet that is glued here to the sides of the stator. One is a north pole, one will be a south pole. On the rotor we have first of all three windings that are located here with the poles of the motor, with the iron here. And we also have what's called a commutator, which is this part here on the rotor. And you can see if you go around that there are three contacts. So what happens is that on one contact you go into one winding, you go several turns over the winding, then come to the next contact, then go to the next winding, go several turns around, come back, go to the third contact, and go to the third winding. So this is a very interesting motor because it's actually three windings connected in what's called a delta configuration, and it's very similar to three-phase AC motors like brushless DC motors, except that here the currents are switched on and off in the windings by through the commutator. And the other part of the commutator is the part that is on the stator. This part has some brushes that slide on the contacts, and these brushes are connected through these copper plates here to the outside where you bring the DC. So the DC comes to these two contacts. You have a spring loading of these brushes so that they apply the current to the plates on the commutator, and as the rotor turns the currents are switched in the different windings with different polarity and creating a uniform torque. Now in many brush DC motors you have many more contacts on the commutator. Here is a motor that is not much bigger but has a lot of contacts here on the commutator, but again the construction is similar. You will have a contact here being connected to a wire. The wire will loop, you will see across here a number of poles, and then when it's finished it will reach the next contact, and then you will go on and so on until you go to the periphery of the rotor. On the stator you have a similar construction with two magnets, a north pole and a south pole, that are glued to the stator. And then the other component on the stator is the brushes. Again you can see that the DC current will be brought to the two contacts here and going through the brush here, and these are spring loaded so that they will press again the commutator, establishing contacts even as the rotor turns. Here's a really interesting example of an unusual motor. This is called a pancake motor. This is an axial flush motor where we have a disc here that's magnetized that produces a flux which will be in the direction of the axis of rotation. We have here the two brushes that bring the current to the rotor, and the rotor is a disc in this case, which looks like a printed circuit board which contains a structure of the winding. Finally, I have here a brush DC motor of a construction where in fact the rotor is very similar to the previous cases, but the stator, instead of having a permanent magnet, has a winding. So the flux of the stator is not provided by a permanent magnet but by a winding that carries a certain amount of current and creates a magnetic field. Now this is a special type of motor where actually the rotor and the stator windings are connected in series, so that would be called a series DC motor. But in fact it turns out that the series DC motor has a torque which does not depend on the direction of the current, so you can actually build them to operate directly on AC. So you see that I have here a standard 110 volt plug, and this motor can be directly plugged into the AC supply and rotate at constant speed and for that matter at a fairly high speed. These motors are typically used in blenders. This is where I pulled this motor from. It's from a small blender.